This technique, dialysis to remove the salt, works pretty well for removing salt from proteins. How do I separate the proteins from each other? Well, there's some ways that I can do that. I can do it by can I use size to separate the proteins from each other? Remember, I showed you, here's a protein, right, that's 104 amino acids, and here's a protein that's 34,000. So clearly they're going to be very different in size. Can I use a technique to separate these proteins based on size? Well, I can. And that technique based on size is called size exclusion chromatography. Also called gel filtration chromatography. Now, gel filtration, the idea is I'm going to use a column that I'm going to fill with porous beads. Porous beads. And these beads can be a variety of different things, but they're usually a polymer of some kind of dextran, which is a sugar molecule, or agarose, or polyacrylamide. So what I'm going to end up with then is a column that looks like this. Now these beads are tiny. These beads are about 0.1 millimeter in size. And they have, so I draw them, they look like this. Here's a bead, here's a bead, here's a bead, here's a bead. Another one, there's another one. Okay, and these beads have tiny little pores that run through them. They're not necessarily the straightest pores, but they have all these pores that run through them. Here's the bottom of the column. Okay? Now, if I put in two sizes of molecules, I'm going to put in big purple molecules at the top, okay? And I'm going to put in pretty tiny orange molecules. Okay? Both are proteins. The orange and the purple are both proteins. What happens is the purple molecules can't fit into the beads, so they have to sort of work their way around in between the beads to come out. Time. Okay? And what I find is that that the purple stuff that works its way around the beads comes out first. In contrast, these orange molecules, they can go through the beads, but they take a long time to work their way through the pores of the beads. And so I find that the orange molecules come out later. Okay, and that's what's shown in this slide here. You can see big yellow molecules, intermediate green ones, really small red ones. The big ones, the yellow ones, come out first. The green ones come out somewhere in the middle, and the red guys that can really get lost inside the pores of the beads come out the last. Okay? Now, to make this technique work well, should I use and these are examples of columns, okay? Two real columns. If I want to separate something by gel filtration, should I have a long, thin column or a short, fat column? Who says short, fat column? Who says long, thin column? Think about it. You want them to separate over time. So the longer the distance that they have, the more they will separate. Yes?
How would you know when the protein actually is coming out?
You don't. We'll get to that. You're just if you can't see it, you're just collecting fractions, and you're going to figure out where the protein was. Okay? So for this, I want a long, thin column, not a short, fat column. Okay. Should I put a lot of sample on or just a little bit? Should I put half my column volume of sample or maybe 1/30th, 1/40th? Who says a whole lot? Who says a little? Yeah, the smaller amount gives it better separation. So this is separation based on size.